So let's kind of look at it this way. On uh, the first graph, the 2x minus 3 is for values that are less than 2. And then the other one, of course, is for values that are greater than or equal to 2. So can you kind of see where this would give me a boundary here with this? Go back to that. So basically everything's going to happen around 2. Now, you need a straight edge for this. Okay? So what I'm going to do is draw a boundary at x equals 2 right there. So everything's going to happen sort of with respect to that. So at 2, where x is 2, I'm going to draw a little dotted line. And so this dotted line is sort of my boundary. And I'm endorsed by Brookshire's, by the way. All right. Like I get paid to do that. I'm just kidding. All right. Now, so what's going to basically happen is that first graph, that 2x minus 3, is got to be for values that are less than 2. So where are values less than 2 with respect to this line right here on the left side? So it's kind of like that first graph, the 2x minus 3, is going to be on the left side, and then the other graph of x plus 3 is going to be on the right side. Does that kind of make sense there? Okay, now let's try to graph those. All right, so let's graph 2x minus 3. Y'all walk me through how to graph that. So where do I go? All right, negative 3, and then we do what? Rise 2, run 1. Okay, so I'm going to draw a line through those 2 points, but the thing is, this line only is going to be on the left side of 2. So when I get to 2, I've got to stop. Okay, let's draw that. It's going to be like this. All right, so well, we're going to modify that. So it can be equal to 2, can it? So how can we show somehow that it goes up to 2, but it doesn't touch 2? An open dot. Okay, I think that's what somebody was saying there, like that. All right, so I know that's kind of not exactly open, but that's pretty close. So an open dot. Now, for x greater than or equal to 2, let's do that x plus 3. Okay, so y'all walk me through this graph. We're going to go right up 3, put a little x right there. And then what's my slope there on my x? Rise 1, run 1. Okay, now the thing is, think about this. Is my line actually going to go through those 2 points? No, because this line is supposed to be greater than or equal to 2, and that's on this side. So this is why I need a straight edge. So I'm going to take my straight edge and line up those 2 points, but I'm only going to draw that to the right of 2. So you understand why it's not going through those 2 points and why I need a straight edge there? So I'll start it right there and then go off to the right. Now on that one, well, it was greater than or equal to 2, so we would include 2. All right, y'all see how that kind of worked there? All right, so you had one that was less than 2, so that was the graph that got on the left side, and then one that was greater than or equal to 2, so that was the one that was on the right side. Okay, does that make sense? All right, yes. Well, not always, because in this case it was like just 2 of them, so you only had one boundary line. What we'll look at in a minute is we'll have one with 2 boundary lines. Okay, so you kind of have like a left and a middle and a right. Right? Now,